Now let's look at the scalar production of two vectors, A dot B. The definition of a vector dot another vector is the first one's magnitude times the second one's magnitude times cosine of the angle between these two vectors. No matter this vector is two-dimensional or three-dimensional or either one-dimensional, that the vector A and B, we can always use two vectors to construct a two-dimensional plane. Therefore, the angle theta is the angle between them. Probably you will say, what about the other angle? That one. Since we know cosine is a periodical function about 2 pi, so we always use the smaller angle theta because the other one is 2 pi minus theta. If you cosine it, it will have the same value. So we always choose the smaller angle between A and B. Now, if vector A, typically, let's express it in the ijk term, that unit vectors, axi plus ayj plus azk. Similar for the B, the definition of magnitude of vector A is its x component square plus the y component square plus z component square square root. So we can imagine that we can do the same thing about vector B's magnitude. Now, the angle theta between two vectors usually is unknown. Because, for example, if I give you vector A equals to 2i plus 3j minus k, that is a three-dimensional vectors. Then I give you another one, B equals to 5i minus j plus 2k, for example. In this case, we can easily calculate the magnitude of A and B, but we do not know the angle between A and B since they're in this ijk term. And how do we find out the value for A dot B? Okay, we have a generic way of doing that. That is, we just use the usual production. So we say A dot B, let's enlist all the terms. That is AXI plus AYJ plus AZK dot BXI BYJ BZK. Now dot simply means time. So let's use our first term to time the other three terms. So we have AXI dot BXI plus AXI dot BYJ plus AXI dot BZK. So you can imagine actually we will end up of total 9 terms because next one we use AYJ to dot the other 3, and last one we use the AZK to dot the other 3. But before we do that, let's take a look at what happened. Now here is I dot I. Now AX, BX, just numbers. So numbers simply time each other. So we have AX, BX as number time comfortably to each other. Now here is I dot I. This is a vector dot a vector. So if we follow the definition of a vector dot a vector is the first one's magnitude times second one's magnitude times cosine of this angle. Now let's pay attention to I dot I. Well, it is I's magnitude times next one's magnitude times cosine. The angle between I is 0 because both I means positive x-axis. So the angle between them is 0. Since I is a unit vector, so magnitude will be 1 times cosine, 0 is also 1. So I times I is 1. You can imagine j times j is also 1, k times k is 1. However, I times j will be 0 because, look, I dot j. That equals to i's magnitude, that's 1. J's magnitude, that's 1, no problem. But cosine 90, because j represents positive of y direction. I represent positive x direction. The angle is 90. Cosine 90 is 0. This tells us that the cross production term, which means I should say I time dot j turn, I dot k turn, or vice versa, k dot I turn, k dot j turn, these are all 0. So what happened is we will end up the I turn survive, j dot j turn survives, k dot k turn survives. So eventually a dot b will result a 3 turns, ax bx, that is the I dot I turns value, plus by ay, plus az bz. Well, if we switch these two numbers, it doesn't matter. So as a matter of fact, that a dot b end up have I dot I turn survive, j dot j turn survive, and k dot k turn survives. Therefore, in our case of original, that our a equals to of 2i plus 3j minus k, and our b equals to 5i minus j excuse me, plus 2k, that the result of a dot b equals to 2 times 5 that turn plus a 3 times negative 1 plus a negative 1 times 2. So the result is 10, negative 3, negative 2, that is 5. So on the other hand, a's magnitude equals to 2 square, 3 square, negative 1 square, square root. That will give us 4, 9, 13, 14, square root of 14. And b's magnitude equals to 5 square plus negative 1 square plus 2 square. That is 30. Because 25, 26 plus 4 is 30. So, as a matter of fact, if we right now say what is the value of a dot b, we already know what's the value of a dot b, that is 5. On the other hand, that equals to a's magnitude and b's magnitude times cosine of theta, that's the angle between a and b. A's magnitude is square root of 14, b is square root of 30, and cosine theta. And cosine theta we can find out. That equals to square root of 14 times 30 as denominator. And it's a time. And that is that. So, as a matter of fact, we do not know the angle between A and B, but we can find out the angle between A and B through this calculation. Now, here is a diagram of vector A and a vector B. And the angle theta is the angle between A and B, the smaller one. Now, since the definition A dot B is A's magnitude and B's magnitude and cosine theta, well, A's magnitude simply means the length. B's magnitude is the length. Let's look at B's magnitude, which is the length of that one, times cosine theta. What is that? That actually gives us the length along the direction of A. So this tells us actually there's something very interesting, because if we separate this B, for example, actually we can have this B as this component, if named B of Y, if this is x-axis, and B can have this B of x. We can separate B by bx, by. So A dot B if we separate our b, that will be bx plus by. And according to what we know, that as a matter of fact, this is the law of distribution, that a dot bx plus a dot by. Now the a dot by term will be 0 because the definition is this one's magnitude and that one magnitude times cosine angle between them. Since a is along the x-axis and by is around the y-axis, is 90 degrees angle, this term is gone. So we have this a dot bx, and since a and bx all point to the same direction, so their angle is cosine of 0, and then we end up a's magnitude. Bx, on the other hand, is b's magnitude times cosine of theta. So this example showed us that when we have two vectors dot each other, actually we can split one vector by using the Cartesian coordinates x and y, and then we dot the other vector, we'll get the same result. This technique we will use very, very often, and I will show you an example when we have a homework problem later. I just used the distribution law of multiplication. I would like to prove it. Actually, there's another one's very useful, that is called the scalar product is commutative. That means a dot b equals b dot a. Why we have to prove that? Because in the future, I said it is another production, which is a vector cross another vector. Then this also means time, but it's different. A cross b, the result is a vector. In that case, a cross b does not equal to b cross a. But here, a dot b equal to b dot a. It's very easy to prove because a dot b is a's magnitude times b's magnitude cosine theta is the angle between a and b. On the other hand, let's look at b dot a. B's magnitude, a's magnitude, cosine of the angle. The angle between a and b and a is same. So you see, actually, mathematically, they're the same thing. That's why they're equal. That's why a dot b equals b dot a. We can all switch the position. Well, how do we prove this distributive law of multiplication? I think it's we can use this technique that about IJK. For example, that how do we get b plus c? Actually, that is bx plus cx of I, because I term add together, we know how to add two vectors, right? So that is by plus cyj and bz plus cz of k. See, we add that b plus c first, and then we can time them just by treating them as the normal production, and we can get that a dot of bx plus cx of this first term is I term, and then we have a dot by plus cy of j plus a dot bz plus cz of k. And then we can continue to move in this a dot that. So eventually we'll be able to get the format of ax bx of I plus ax ay of by of j and this and that. So you can continue to finish that. We just do the calculation for the left and do the calculation for the right, following the rule of a dot production, and then compare each term. If eventually if both sides have the same, exactly same number of turns, then the format and we say they are equal.